Okay, the wording on this last one is the hardest part of this problem. We're given some language that says some potassium, what's the name of this? This is number 65. A student titrates an unknown amount of potassium hydrogen phthalate. And essentially, this is just an acid, but it's not in a solution, it's a mass that we're looking for. And it says that we titrate it with 20.46 milliliters of 0.1000 molar sodium hydroxide. And it tells us that the molar mass of this compound is 204.22 grams per mole, and that this has one H to donate. So essentially this H and this OH are going to make water, and everything else that's in this compound is going to make an unusual salt. But we know acid plus base makes water and salt, so we'll just leave it like that, and we won't worry about this because we really don't need to. We're asked for, what is the mass of this? That's the question. So if we find out the number of moles of sodium hydroxide, and we know that this is a 1-to-1 because what the information says that this has one hydrogen to give. If this has one hydrogen to give, it's going to balance with the water to make one water, and the rest of this will make a salt. So that's the hardest part that might be difficult to guess what this reaction would be. This is a very common way to determine the concentration of sodium hydroxide before you start a reaction, because this is a very stable compound that we can use. So essentially, we're just going to do a stoichiometry calculation. I multiplied the volume times the molarity to get the number of moles of sodium hydroxide. So we know we have that much sodium hydroxide. We know we're going to have 1 mole of this potassium hydrogen phthalate, which sometimes is abbreviated KHP, for 1 mole of NaOH. So that means that we're going to need 0.002046 moles of this KHP, which is just this abbreviated. This is KHP. Okay, well, we know the molar mass, so 0.002046 moles of the KHP times 204.22 grams for every 1 mole of the KHP. That's just abbreviating it again. And if we multiply that, we're going to get 0.418. So if I go in the stockroom and I grab the container of this, it's a solid salt. If I had 20.46 milliliters sodium hydroxide at 0.100 molar, that means I have 0.002046 moles of sodium hydroxide that I'm trying to neutralize in this sample. And I would need 0.418 grams of KHP. And you can visualize how much that might be based on the labs we've done. It's not a lot of KHP to neutralize that sodium hydroxide sample we have. And that's all there was to number 65. But it was worded in a challenging way because this is an unusual substance that you haven't seen yet.